Here we have the definition for negative exponents, right? So we define a negative power as the multiplicative inverse of the base raised to the positive opposite of the power. That's very mathy language. But what they show here is what we've seen before in terms of how a negative exponent is defined. Let's take a look at some examples here. So if you had 3 to the negative fifth, right here, you would express that as 1 over 3 to the fifth. And so when we move this power to the denominator, right, we then make that exponent positive, right? So if you see 1 over 2 to the eighth, that could be expressed with a negative exponent, right? Because the negative exponent means that this power was in the denominator. And just how this works with numbers, you could also have a variable, y to the negative 2. We would put a y squared in the denominator. Here you see a flipped version of the fraction, and that's because the exponent was negative, right? So the negative exponent means that whatever's in the denominator will go in the numerator, whatever's in the numerator will go in the denominator. All right, so here, let's practice with this, all right? Now, we have 4 to the negative third. This doesn't mean that my expression's negative, right? In fact, this number should be positive. The exponent is negative, right? Now, this 3 stays with the base, a base of 4, so it's not going to be B. I'm going to say it's C. Let's check. Hey, I got it, right? And here they show, this is pretty much exactly what the definition was before. Here, I'm going to go back up and look at that definition. So they're saying x to the negative n is equal to 1 over x to the n. So what they're writing here is exactly the same thing. Instead of variables, it's numbers. 4 to the negative 3 is equal to 1 over 4 to the third, right? All right, so we had looked at powers of 2 in my previous negative exponents video. I had used a table just like this. Notice here, right, anything raised to the first power is just itself, right? Anything to the 0th power would come out to be 1, right? And in that previous video on negative exponents, I talked about 2 to the negative 1 is 1/2, and 2 to the negative 2 is 1/4, right? Notice how 2 to the n is divided by 2 each time we reduce n. This pattern continues even when n is 0 or negative, right? So 8 divided by 2 is 4, 4 divided by 2 is 2. That continues, right? All right, here it just shows with a previous property we used with division, right? And so 2 squared divided by 2 to the third, we would be subtracting the exponents. You get 2 to the negative 1. Here they show with expanded form, and we still have a 2 in the denominator, right? And 2 to the negative 1 is equal to 1 over 2, right? Here we see them using the multiplying property where we add the exponents, and 2 plus a negative 2 comes out to be 0 or just 1, right? Likewise, 2 to the negative 2 can be expressed as 1 over 2 squared. And if you're dividing 2 squared by 2 squared, you also get 1. All right, so this was a review of negative exponents. You guys had done a negative exponents assignment before. If you haven't completed the past negative exponent assignments, you should go back and complete that. And I'm going to be assigning an additional negative exponent assignment so you guys can get some more practice.